Hello, and thank you for listening to my talk about my experiences with Oracle today. I have some experiences with Oracle. I'm an experienced person, as you can see from my gray hairs here, and some of those gray hairs have certainly been caused by Oracle. But yeah, enough of that small talk. Let me present my talk. Yeah, about stumbling stones when migrating from Oracle. So before I start, let me waste a few words about myself and my company. I'm Lawrence Albee. I've been working with PostgreSQL and contributing to the project since 2006. I maintain the Oracle Foreign Data Wrapper, which hopefully gives me some credibility in that area. I do support training, consulting, and development in Postgres and related fields. Do that for my company Cybertech, where I've been working since 2017. A few words about Cybertech. We do all the aforementioned things for you. We also have a branch, besides our Postgres services, of data science. So if you're into machine learning or making sense of big data, we are also there to help you. We are all over the world, and so are our customers, some of our present and past customers you can see here. Okay, you know where to find us when you need us, but now let me move on to my actual talk. This is the agenda. I will talk about the obstacles when migrating from Oracle in all these different fields. And finally, I will also give you a few hints about Oracle migration tools. So an overview. These, I tried here to split migration into several distinct steps. First, basic understanding of open source software, the differences between Oracle and Postgres, and then the actual parts of the migration, the data definition language, create statements, the data themselves, the code in the database. I like to call it stored code. I mean by that functions, procedures, packages, whatever procedural code is stored in the database. Then the SQL statements, and finally obstacles you could meet when migrating the application itself. So on this slide, all these points have the same size, but in reality, they won't give you the same amount of trouble. And on this slide, I try to present it in a more realistic size. So the actual data migration that people think is the big thing about it is usually a small part of the whole affair. And dealing with stored procedures, for example, is usually much more troublesome. So, okay, let's start at the beginning. Understanding open source and PostgreSQL in particular. On this slide, I've just collected a few of those statements and problems that people might have when they first encounter Postgres open source at all. Those is mostly people who come from a closed source background, like an Oracle shop in our case. It's these days, people more and more know about open source and use open source already. So you meet some of these questions less than you're used to, like, is this actual software that can be used in an enterprise? Yeah, everybody knows that, for example, Linux can, and most people today believe that Postgres can. But there's still some obstacles, people wonder about support. How do I get commercial support for an open source project? Sure, you can. Yeah, you can from more than one company, like from our company or from our host Enterprise DB or other competitors. You can get support by people who know the code. Huh? A serious concern is about integration. When you have Oracle, you have everything from Oracle, like backup solution, enterprise manager, and so on. If you use Postgres, you move to Postgres, you have to piece it together yourself. You have to select the backup software, integrate it with your Postgres setup. You have to think about monitoring, which tool to use, and so on. So it's cumbersome. You have more integration work. This, yeah, is kind of a shift, but in exchange, you often get more choice. That's the upside here. Yeah, I won't stop so long with these things. This is often more a question of mindset and discussing these things and pointing out how things are done in the open source way. For some more technical differences, both Oracle and Postgres uh, look pretty similar from the user end when it comes to multi-versioning. They don't have read logs, so mostly it looks the same. Not totally though. But the differences are under the hood. Oracle maintains old data in an undo table space and writes them back on rollback. So rollbacks take much longer. There's a lot of advantages that Postgres has in this area. One of those, for example, is that there's no need to cut big transaction like large deletes into smaller batches in fear of exhausting the undo table space and getting snapshot to old error. So often things become simpler in the Postgres world. But there are, of course, also downsides with our architecture. In particular, Postgres is not very good at handling update-heavy workloads. We end up with a lot of dead tuples, and we may need to tune auto vacuum for that. And if that is not enough, then we possibly have to change our data model and our workload so that we can get hot updates. That could mean creating fewer indexes than you would like to have. But yeah, so there are ways to deal with that, but this is often a problem point. A small thing to consider is that tables and databases typically are bigger in Postgres than they are in Oracle. That is because in Postgres, every row has an overhead, considerable overhead. Most of that is for the visibility information. Then something that you also that also happens is in Oracle, if in a transaction a statement causes an error, then not the whole transaction is rolled back, but only that one statement that caused the error, and the transaction goes on. So Postgres does it differently. We cancel the whole transaction. So if you want to kind of emulate or get back the Oracle behavior, you have to use save points, but yeah, you have to change your code. You have to think about when to do that. That can be a difficulty. Something about schemas, users, and synonyms. So the Oracle model is much simpler. Schemas are tied to users. They always go together and have the same name. So it is maybe a bit difficult for Oracle people to understand the Postgres model at first. And to deal with these shortcomings, Oracle has synonyms. Those are kind of aliases, objects that just point to an object in a different schema. So you can use that object without having to qualify it with the schema name. People often wonder, where are my synonyms in Postgres? But the truth is you usually don't need them. Usually an appropriate search path setting can do the same thing. And if that's not good enough, then you just create the view and that does the same thing. Okay, but views a little bit. In Oracle, views do not have dependencies on the objects. So you can drop a table even if you have a view defined on top of it. The view then becomes invalid, and if you try to use it, you get an error. Postgres is much stricter about that. We track these dependencies, and in order to drop the table, you have to drop the view too. So your schema upgrade procedures may become more complicated. You have to drop those views, change the tables, create these views again. It can be done, but it's something where you have to change your procedures perhaps. On the upside, we have transactional DDL, so you can run all this in a single transaction and it's much less disruptive for production. About materialized views, We have the two in Postgres, but the Oracle material views are much more sophisticated, have much more options. For example, you can have on commit refresh materialized views that change immediately if the underlying tables change. We don't have that in Postgres. If you need that, you can write it by hand, usually using triggers on the underlying tables. So it's also a small obstacle here. A word about table spaces. They are a very important thing in Oracle, but not so in Postgres. Usually you don't use them at all. So it's mostly, again, a question of mindset. You have to dissuade the people from creating lots of table spaces in their Postgres database if they don't need them. Now let's get to the migration steps. The first is the DDL migration, migrating the create table statements. The biggest consideration here is the data types you should choose. Postgres has way more data types than Oracle, so you're never at loss for finding a data type, but often you have the question which one to choose. For example, with Oracle dates, there's always a time component included. So you have to decide, do I need that or not? Shall I migrate them to date or to timestamp? The bigger problem is number even, because although Oracle has 3 numeric data types, people always only use number, which corresponds to Postgres numeric. Now, you do not always want to translate those to numeric because numeric is slow, takes more storage, and so on. So often you want to migrate to integer or double precision or something like that. So you have to know the data, have to understand the data, have to make a decision here. Also consider foreign keys because, of course, for foreign key to work, both columns have to have the same data type. So if in Oracle one of those numbers is constrained, say to number 5, to a 5-digit integer number, and the other is not, you can have a foreign key constraint in Oracle. But if you migrate the first one to integer and the second one to numeric, you won't be able to create a foreign key in Postgres. So you have to migrate both of these columns to the same data type. Yeah, finally, binary large objects. There is the potential choice between byte A and large objects in Postgres, but the proper choice is always byte A, I tell you. Okay, data migration, I said, is easy. It's comparatively easy, yes. Oracle tries to make it hard by not providing any tools to export the data in clear text, but that can easily be worked around with programs. As I said, it is not a complicated step. The challenge here is that most of the downtime during migration comes from the data migration. So if you want to keep the downtime short, there are several options. The simple option is to parallelize, to migrate tables and indexes in parallel, so you can be faster. If you have even higher requirements, then you need something like change data capture, where you first move the data over, but track changes on the Oracle database so that you can replay them on Postgres later. In a way, you have some kind of logical replication between Oracle and Postgres. Then you can just switch over with a very short downtime. Such facilities are typically, unfortunately, only available with commercial migration tools. What problems can you encounter during data migration? One thing that happens more often than you would expect is corrupted stream data. Because in Oracle, if client and server encoding are the same, Postgres makes no attempt to validate the data. So you can write any garbage to the database, and sometimes people do. This can typically only be fixed by cleaning the data at the source, because Postgres is much more picky about that and won't allow such wrong characters to be migrated. You can also have 0 bytes, ASCII null bytes in an Oracle string. You cannot have that in Postgres, so you have to strip those out. That's something that you usually can do automatically, but you have to do it. And finally, there's infinite numbers that few people know about in Oracle. They're represented by tilde and minus tilde. If you migrate the number to double precision, you can map it to infinity, but otherwise you have a problem and you have to think about some other value to use, or maybe a null. Depends on the situation. Yeah, for the big topic of stored procedure code, one would naively expect that this is simple because, after all, PGSQL is just a clone of PLSQL. But the differences are sufficiently big. As a simple example, the create function statement in Oracle has return, whereas in Postgres it has returns. Well, that's easy to fix, but you have to do it. There are some tools that provide an automated translation with varying quality, but tell you it will never be perfect. It can be more or less good, but it's going to never do everything for you. A few of the frequent problems you meet is, for example, transaction statements in the code. In Oracle, you can have commit and rollback in functions and procedures. You cannot have that in Postgres functions. There's limited support for it in procedures, but it's usually not enough. So if that is just a case of batch deletes, as I described before, where people just chunk a big delete in several parts and commit in between, you can just do away with the transaction management because you don't need it in Postgres. In other cases where you need it, you have to kind of rewrite or rearrange the code and shift the transaction management to the application side. With Pragma autonomous transaction in Oracle, you can have an independent sub-transaction that can commit, for example, whereas the outside transaction is rolled back. That can be useful to write log entries to table, but undo the overall transaction. We cannot do that in Postgres. A way to work around that is the DB link extension, with which you can create a link back to the database itself, and in that way have a second transaction that you can commit even if you roll back outside. And finally, you sometimes meet the bulk collect. That is an Oracle construct with which you write a whole batch of rows from a cursor to a set, to an array of variables. We don't have that. It's a performance feature. So you have to do without and just simplify the code and process the data row by row. There is no better way for that. About packages. Packages are a very nice and useful thing in Oracle. It's basically modularizing the code, so tying several functions and perhaps types and data together. We don't have that. So one option to have in this area is to use Enterprise DB's closed source fork. They have an implementation for packages that will cover much of that. So you have few pains when migrating these things to Enterprise DB. Sometimes you can do much simpler. If it's not a very complicated package, then you can translate it into a schema. And the functions in the package just become functions in the schema. So then the syntax for calling those functions would be the same, even though it is not really a package anymore. Another problem is that Oracle ships with a very large library for use in PLSQL. You can do anything from sending HTTP requests to accessing the file system. You name it, it's there. Yeah? So people use that, of course, and we don't have it. So what can you do apart from using the closed source fork that provides many of these things? There is Aura FCE. It's an open source extension that has some of these things and makes the shift a little bit easier. Another good choice is to just move that stuff out of the database and to the application. Often that's better anyway. Huh? But you can also have it in the database in Postgres, but then you have to rewrite the code in either PL-Perl or PL-Perl or PL-Python. One of those two is typically the right choice here. So there's work for you here. Triggers are not so problematic. There is a syntax difference in that an Oracle trigger contains the code in the create trigger statement. Whereas in Postgres, you have a trigger function and a create trigger statement. So that's usually a trivial modification, but it has to be done. Sometimes you can just forget about those triggers. In Oracle, you need a trigger to fetch the next value from a sequence. We don't need a trigger for that. We just write it into the column default, and it's much simpler. One thing that we do not have in Postgres and that people sometimes use in Oracle are log-on triggers. That's triggers that run after a database session has been established. We can't do that, so either shift that logic to the application or do without, but there's no replacement. Yeah, but migrating SQL, where does SQL come from? First and foremost, of course, from the application code. Depends. If you have object relational mappers or some other abstraction layers, then this can be very little that's directly generated, can be much. But SQL comes from other sources too. You have SQL in view definitions, in PL/SQL code, you have SQL statements, you have column default clauses, and perhaps in functional indexes, some SQL code. All that has to be translated. Often, if you write standard conforming SQL, that's not such a big problem, but nobody ever does. So a few highlights or lowlights, if you want, of problems with migrating SQL. First, there is the Oracle outer join syntax with the plus here. That's old, and Oracle has the standard conforming syntax now, but sometimes you encounter these things. They're always easy to translate, but of course it's annoying. Something that's even more annoying is that Oracle treats empty strings as null values. That in itself is not such a big problem, but as a consequence, in string concatenation, Oracle treats null like an empty string. So if you concatenate null to a string, you do not get null as you get in standard SQL. So wherever you have those string concatenations, you have to watch out. Either translate it to concat, use the concat function that does exactly what Oracle string concatenation does, or you sprinkle your code with those coalesces that replace empty strings, null values with empty strings. It's a frequent problem, not hard, but a lot of silly work. Yeah. Very often you have the Oracle proprietary functions for current time, sysdate and systimestamp. Although Oracle supports the standard functions, people rarely ever use them. So very often you can just get away by search and replacing that with clock timestamp, which would be the closest correspondence. But sometimes you might prefer to use current date or current timestamp. Okay, and finally, a little bit about sequences. In Oracle, you fetch the next value from a sequence by sequence.nextVal, like as if it were a column. Whereas in Postgres, you have to call the nextVal function on the sequence. So again, a simple thing, but you have to do it wherever sequences are used. Finally, migrating the application itself. This can be hard, it can be trivial. Most of the trouble is the SQL that's generated. So if you do not generate your SQL yourself, you use an object relational mapper or something like that that generates the SQL for you and ideally supports both Oracle and Postgres, very often you can get away with nothing at all. Just change the driver and the connection string and there you go. But it's not always that easy. And if the SQL code is generated all over the application in different functions pieced together, it can be really cumbersome. So it depends. No matter if it's easy or complicated, the big thing here is testing. You have to test it really thoroughly because there are some things, particularly things that with regard to concurrency or transaction handling, that will only surface or make problems here during testing, not in the static code. Okay, now that I've covered the basis of the different steps and what the problems are, something about the tools you have. I will only present a small selection. The first is not a tool as such, but it is which Postgres you want to use. Do you want to use standard Postgres, or you have the alternative to use Postgres forks that support this kind of migration better? Most notable is Enterprise DB's closed source fork that provides good compatibility and really makes your migration work easier. But do not believe any claims that anybody might possibly make it. This is a drop-in replacement. You have to do nothing. That's not true. Yeah, it's marketing talk. Also, think if you want to end up with an open source product and have all the advantages of open source, or if you want to end up in another closed source cage, just the cheaper one. So it's up to you. Then, as I mentioned, there's Aura FCE, the extension that provides a little bit of compatibility, some functions, some package substitutes that can make your life easier. Often it's a good idea to do the extra work if you have to touch the stuff anyway and migrate so that you end up with open source PostgreSQL and have the full power and all the advantages of open source. The most frequently used tool for Oracle migration is Aura2PG, a time-tested Perl script. It has been used very often. It works. It's not totally bug-free, as I've personally experienced, but it's decent. It generates a DDL script out of the Oracle metadata that you then have to edit and adapt to your needs. And it exports and imports the data for you. Of course, this export and import, if the database is large, can be pretty time-consuming. Aura2PG makes an attempt to translate PL/SQL, but that's a rather simple attempt. There's my baby Aura Migrator. I wrote that because I wrote the Oracle Foreign Data Wrapper and wanted to make use of that. So it uses the Foreign Data Wrapper to extract metadata and data from Postgres, from Oracle, where I'm at. This is also its biggest disadvantage. You have to have Oracle Foreign Data Wrapper in the target database. So if you have a hosted database, that's usually not an option for you. Also, it does not make no attempts to migrate PL/SQL code. On the plus side, it directly moves the data from the Oracle database into the target Postgres database, so the migration is fast. You can also parallelize it with a little bit of effort. It's, in a way, Aura Migrator is a toolbox that enables you to write your own migration scripts easily. And I also wrote a simple replication solution for shorter downtime while you migrate, but it's a rather crude solution that places triggers on all the Oracle tables. So it may work, but you certainly cannot afford it on all Oracle production machines. Of the commercial tools, I only want to show you one because it's the only tool I kind of know. That's our migrator, Cybertech Migrator. It's a commercial tool, yes, but it provides highly parallelized data migration and very good quality PL/SQL conversion. Not perfect, of course, I told you that's impossible, but good. Yeah? And it has a nice graphical user interface that allows you to do that comfortably without writing any scripts, and also reusing a migration if you have several similar databases. And we are currently developing a change data capture solution for near zero downtime migration. Okay, you see the URL down here. It may be the right thing for you. Okay, so I'm now at the end of my talk, and I think there will be questions now. So thank you for listening to me.